In this presentation, you will learn about the physics of bowling. We will focus on the three primary aspects of the game: the ball, the lane, and the pins. Modern bowling balls cover stocks, or outer shell, are made out of polyester, urethane, or reactive resin. The ball on the right is polyester, commonly referred to as plastic. The balls on the left are reactive resin. Polyester balls do not like to hook, which can be seen here, but if you slow down and put some extra RPM on the ball, you can get some movement. Reactive resin balls are the complete opposite. Their cover stock has a unique chemical composition to create microscopic holes in the cover, which increases the friction between the ball and the lane. This allows them, especially the stronger ones, to hook sharply. The other component of the ball which allows it to hook is the core. The core is either symmetrical or asymmetrical. A symmetrical core creates a smoother motion, while an asymmetrical core creates a hard turn. The core on the left is a symmetrical core from the red ball. The core on the right is the asymmetrical core from the black and gold ball. There are many different core shapes that are currently in use. The most common core is a pancake core. It's used in polyester balls because it does not promote the ball to hook. This core is also used in higher end balls that are under a certain weight. This is because no matter what the weight of the ball is, the core weight stays the same. This means usually balls under 12 pounds have a pancake block. Bowling balls have a 27-inch diameter and weigh between 6 and 16 pounds. The variation in weight is achieved by using different ratios of heavier and lighter minerals around the core. The following clips will compare the different core types. We'll start with the symmetrical core. Note the smooth but strong hook of the ball with the symmetrical core. Also note how the ball gets into a roll before hitting the pins. The way the ball is drilled in relation to the core is what allows it to get into this roll. This way the ball has traction when it hits the pins and doesn't get deflected very easily.
I haven't gotten single spin.
Now look at the ball with the asymmetrical core. Note how it has a much more sudden hook down lane. Like the symmetrical core, the ball gets into a roll before hitting the pins. Now we'll talk about the lane. The lane is 60 feet from the foul line to the pins. It is made out of either wood or synthetic material. These shots were recorded on a wood lane. There are very minor differences between wood and synthetic. To understand these differences, you need to understand how the lane is oiled. This is a simplified diagram of a house shot. A house shot is a lane condition that is easy and promotes high scores. Note how there is not any oil at the end of the lane. The last 10 to 25 feet are always oil-free. What makes the house shot easy is a lack of oil on the edge of the lane. This means if you throw a ball that hooks and get it too close to the gutter, or throw it too close to the middle, the oil is placed in such a way where you can miss by around 5 inches and still hit where you wanted to. This is where the difference between wood and synthetic come into play. On synthetic lanes, like the one pictured here, the ball does not like to hook at all on oil, but is very strong where it's dry. Wooden lanes are the opposite. The ball will hook a little on the oil, but will be slightly weaker where it's dry. An example of this can be seen in the following clip. Note how the ball hooks early and manages to stay on the lane. Here are some examples of patterns professionals bowl on. These are much more difficult than a house shot and only allow for an inch or two of error. Note how the patterns have very different lengths. The red line represents a common ball motion for each pattern. On shorter patterns, the ball has more time to hook, so the ball will often be thrown angled opposite of the way it hooks. This brings us to our final topic, the pins. As I said earlier, the pins are 60 feet from the foul line. They weigh about 3 pounds each, and there are 10 of them. The point of hooking the ball is to get it to hit the pins at the optimal angle. The angle is important because the ball only comes into contact with around half of them. The others fall because of pins hitting each other, known as pin action. The optimal angle has been calculated to be around 6 degrees. This may not sound like a lot, but to achieve this with a straight ball, it would require the bowler to stand on the next lane over. In the following clip, you can see how a ball without enough angle will leave pins standing, even if the ball hits the pocket.
Follow the ball. Come on. Hey, there's a pin in the middle. There's a pin in the middle.
Pin action is also very important when it comes to picking up spares. Often the ball will not physically be able to hit both pins, and it will be up to the pin that is hit to knock the others down. This can be seen here. Angles are important in situations like this too. The ball must hit the first pin at the right angle so that the pin heads in the direction of the others. If the angle is off, something like this will happen.
The ball's going like 10 miles per hour.
This strike montage will conclude our presentation.